Hello, algebra students. This video is going to be on our lesson called Which Variable to Solve For. Notice that this is part 1, so we are starting this topic today, and then we'll be finishing it next week on Monday. For our warm-up, we've got this table right here, shows the relationship between the base length B and the area A of some parallelograms. All the parallelograms have the same height. Base length is measured in inches, and the area is measured in square inches. And our goal is going to be to complete this table. If you're wondering, a parallelogram is just a type of shape. It's a shape that looks, if I could draw straight lines, kind of like that, so kind of like a diamond. But they're just telling us that if the base is this value, keeping in mind that the height's staying the same, these are the areas. In order to help us fill out this table here, they've given us these first couple rows already filled in. See if you can notice a pattern in these first 3 rows there. I notice that each time, if I'm given the base to get to the area, what is happening? Well, each time we're taking that number in that first column and multiplying it by 3 to get that area. Taking the base, multiplying it by 3 to get the area. Taking the base, multiplying it by 3 to get the area. You can use that observation and that pattern to help you fill out these next two. If I'm given the base is 4.5 inches, or the base is 11/2 inches, how many square inches would the area be? Go ahead, try those two now and pause the video. Well, we're going to do the same thing that was happening in those first 3 rows. We're going to take that base, we're going to multiply it by 3, and it's going to give us our area. For this first one, that works out to be 13.5. For the second one, if you take 11/2 and multiply that by 3, might help you to change 11/2 into a decimal first. That would be 5.5. But either way you do it, when you multiply that out, it's going to give you 16.5 square inches. So I'm noticing from here that what are we doing each time? Well, I'm taking that base in inches and multiplying it by 3 to get our area. Using that observation we just made, our goal over here is there are 4 equations. We want to figure out which equation or equations represents the situation. Take that observation you made for these first 5 rows now. What equation would represent that? Well, what did we do each time? Each time we were taking our base and multiplying it by 3 to get our area. So I could write out that sentence we've been saying as B times 3 equals A. Or the base length times 3 gives us the area. This equation, it's not written exactly like that over here, but there is a similar equation. Instead of saying B times 3 equals A, they've written it as A equals 3 times B. Those equations are saying the same thing, saying the area equals 3 times the base. The base times 3 equals the area. Now notice for these last 2 rows in the table, they've given us different information. Instead of giving us the base, they've given us the area. And I need to go backwards to figure out what the base is. In order to do that, what am I going to need to do? Well, moving forward in this table, to get from the base to the area, we were multiplying by 3. If I want to go backwards, I'm going to have to divide by 3. So I'm going to have to take that 36 and divide it by 3 to get our base, which 36 divided by 3 gives us 12. For this other one, we've got 46.5 as the area. In order to find that base, we're going to have to do the exact same thing. We've got to take that 46.5 and divide it by 3. And when you do that, you get 15.5. So notice here we were doing something different. We weren't taking our base and multiplying it by 3 to get the area. What were we doing for these last 2 rows? In these last 2 rows, we were taking our base and dividing it by 3. We're taking our area. Sorry. We're taking the area, that last column there, and dividing it by 3 to get our base. Now, I've written it like that. Do you see another equation over here in these 4 options that says the same thing as A divided by 3 equals B? Yeah, we've got this one right here. So another equation you could use to represent this relationship is the base equals the area divided by 3. You could check one of these ones we did earlier. Is our base equal to the area divided by 3? Yeah. Now, if we look at these other 2 equations here, the first one says the base equals 3 times the area. That one is not true. Our base does not equal 3 times the area. That one does not represent this relationship. The other one said the area equals the base divided by 3. Check that. Does your area equal the base divided by 3? Also not true. So the 2 equations that represent this relationship here are B and D. Now look at those 2 equations. In the past 2 lessons, we've talked about equivalent equations. Are the equations from B and D equivalent equations? How do you know? Those 2 equations there are equivalent equations. They're equivalent equations because they're representing that same relationship. And these numbers, these pairs of numbers, would be solutions for both of them. They're describing the same solution. Now, if you had one of those equations, you can get from one of those equations to the other. And that's going to be one of the focuses of what we're doing today. If I take that first equation you guys wrote, which was A equals 3B, notice the other equation, the equation we got second, instead of saying what A equals, it says what B equals. We could rearrange this equation here to, instead of saying what A equals, to say what B equals. And that, notice, is the objective of this lesson, is rearranging equations for a certain variable. Instead of having it say A equals, I could get it to say B equals by doing what operation on both sides. If I'm trying to solve for B, it means I need to get rid of the 3. This is 3 times B, so I'm doing the opposite. I could come in here and divide both sides by 3. And if I do that, it gives me A divided by 3 over here on the left side. And then on the right side, those 3's are going to cancel out and just leave you with B. And notice that equation we just wrote happens to be that other equation we've got here. In today's lesson, we're going to focus more on how you do that rearranging, and why would we want to do that? I've already got one equation. Why do I want to rearrange it to look like another equation? To help us explore that question I just posed, we've got our second activity here, which is called post-parade cleanup. In this activity, it says, after a parade, a group of volunteers is helping to pick up the trash along a 2-mile stretch of a road. The group decides to divide the length of the road so that each volunteer is responsible for cleaning up equal length sections. So just pausing there, what is going on in this problem? Well, there is a 2-mile stretch of road that needs to be cleaned up. And they're saying there's this group of volunteers cleaning it up, and they're trying to figure out how much each volunteer has to clean if everyone is going to be cleaning up an equal length section of that road. If you've got 2 miles and there's only 1 volunteer, that means that 1 volunteer is cleaning the entire 2 miles. However, if you had 8 volunteers, there's 8 people doing the cleaning. How long of a section would each volunteer have to clean up? Well, if there's 8 volunteers, that means we can take that 2-mile stretch and we can divide it up amongst those 8 volunteers. If you do that, that means we got to do 2 divided by 8. 2 divided by 8 equals 0.25. Means each volunteer would have to clean 0.25 miles of the road. Well, what about 10 volunteers? Well, 10 volunteers, that means instead of dividing those 2 miles by 8 volunteers, we're now dividing up between 10 volunteers. So I would have to do 2 divided by 10, and that's going to give me 0.2 miles. Notice with more volunteers, they get to clean up less road. That last one, 25 volunteers, well, same thing. We're taking the 2 miles and dividing it by 25 volunteers. So we need to do 2 divided by 25. When you do that, that gives you 0.08 miles. We've done some calculations here. The next part is asking us to write an equation that would make it easier to find L, which is going to represent the length of a road section in miles for each volunteer, if there are N volunteers. Basically, what we're doing, take all these calculations you've made, make some observations, and come up with a general rule. In general, write an equation for the length each person's cleaning up, depending on N number of volunteers. Well, each time what we were doing is we were taking 2 and dividing it by the number of volunteers, which they're telling me, let's use N to represent the number of volunteers. If you do that, what does it equal? Well, it's going to depend on how many volunteers. So we can represent that length that they would be cleaning with the letter L. I'm going to make it capital just so it doesn't look like the number 1. We get this equation here represents this relationship. 2 divided by the number of volunteers is going to tell us how long of a section each volunteer is cleaning up. Now we've got this equation here that we could have used if I told you any number of volunteers. So let's say I told you, I don't know, there was 100 volunteers. This equation here makes it nice and easy for you to figure out how long of a section each one would have to clean up. We would just take the 2 and divide it by N, which is the number of volunteers, which here is 100, and that would give us the length in miles each volunteer would have to clean. Now we're coming down, same situation, but a different question. This time, I'm asking you to find the number of volunteers in the group if each volunteer cleans up a section of the following length. So basically, to use the calculations we were doing for earlier, instead of telling you there's 8 volunteers, how long does each volunteer have to clean up? I'm telling you each volunteer cleaned 0.25 miles. How many volunteers were they? So it's like flipping the question around. So the first one we are given is 0.4 miles. If each volunteer ended up cleaning 0.4 miles, how many people were there? Go ahead, pause the video, see if you can figure it out now. Well, I'm going to use this equation we had calculated earlier to help us figure this out. Before, we had said 2 divided by N equals L. 2 divided by the number of volunteers equals the total length each person cleans. We're given that length this time around. So I've got 2 divided by N equals 0.4 miles. You can try to figure this out by saying, well, 2 divided by what number is going to give me 0.4? Or you can treat this as an equation that you want to solve. If I wanted to solve the equation 2 divided by N equals 4, I'm just going to change the way it looks to 2 over N equals 0.4. That's just a preference of mine. If I went to solve this equation here, what's that first step we want to do? Well, we want to come in, and to get rid of this fraction, I want to multiply by that bottom number. I want to multiply by N. Right now it says we're dividing by N. I want to do the opposite, and the opposite of dividing by N is multiplying by N. When I do that, those N's are going to cancel out, and we get 2 equals, on my other side, I've got 0.4 times N. I can leave it written like that, or I can just go ahead and say, well, 0.4 times N is just 0.4 N. And let me try making that decimal point a little bigger. After that, the last part is solving for N. We're still trying to figure out N because we're trying to figure out the number of volunteers. So to finish this up, I'm going to come in and divide both sides by 0.4. And when I do that, on that right side there, Those 0.4s cancel out, and we're just left with n equals, and then on that left side, 2 divided by 0.4, type that into a calculator, it's going to tell you we get 5 equals n. So if each person is cleaning 0.4 miles of the road, that means there must have been a total of 5 volunteers. And I'll go ahead and put that down. 5 volunteers. When it comes to solving this equation here, some students also think of cross multiplying. So if you wanted to set it up as 2 over n and then equals the 0.4 over 1, you can always do that as well, and it's going to give you the same answer. Basically, what's going to happen is you're doing the same thing, though. You're going to have to multiply that 0.4 times n, like we got here, and then the 2 times 1 gives you the 2 that we had on the other side. Now notice this math and how this math we just did to answer this question compares to the math we did from earlier. Do you find one of these scenarios easier to calculate and one of them more difficult to calculate? Well, I personally think this one was a lot more work. Before, we were just taking 2 and dividing it by the number they gave us each time. It was pretty straightforward. But this time around, when I substituted that 0.4 into my equation, I ended up getting an equation that I had to solve with more complicated steps. The reason for that has to do with how this equation is set up. This equation is set up to tell me what L equals. This equation is set up to tell me how long each person is cleaning up that road. So it's set up to give me this answer right here, not to give me how many volunteers there were. We could calculate how many volunteers for this next problem the same exact way. I could take this equation, substitute 2/7 in for n, or I said in for n, I'm sorry, in for L. Or we can take this equation and let's start off by rearranging it so that it equals what I'm trying to find. In other words, let's take this equation and instead of having it equal how long of a section each person wants to clean, let's have it equal n instead, since that's what I'm trying to figure out. It's going to be similar to what we had done up here when we took this first equation and solved it to give us that second equation. In this scenario here, our equation is 2 divided by n equals L. I'm not going to substitute yet. Instead, let me change this around so that instead of saying equals L, it says equals n. When we go to solve this, it's going to be similar to when we were solving the related equation before. If I'm trying to get n by itself, let's start by getting rid of this fraction and multiplying both sides by n. If you are a cross-multiplying person, you could cross-multiply it to do that, or we can just come in and say, let's multiply both of these sides by n. I'm going to multiply here by n, and I'm going to multiply here by n. The reason I've chose multiplication is because right now the equation says dividing by n, and I want to do the opposite. Opposite of dividing by n is multiplying by n. When I do that, anytime we do the opposite, those are going to cancel out and just leave me with my 2. And then on the other side, we've got L times n. Remember, I haven't substituted in anything yet, so I've got both variables still there. We could leave it as L times n, like it's written right there. You can also just put them right next to each other. Remember, it's similar to what you did up here with the numbers. You took out those parentheses and you just wrote them next to each other because we know when things are next to each other, it means multiplication. It's up to you, whichever one you prefer. Now remember, what's our goal here? We said we were rearranging this equation so that instead of equaling L, let's make it equal n. So my last step, and I'm going to come down here with it, my last step is if I want it to equal n, look at the side of the equation with n on it. If I want it to equal n, that means I've got to get rid of L. Now we just said Ln, that means L times n. So right now that n is multiplied by L. I want to change it around by doing the opposite and saying, let's divide by L. When I do that, we get 2 divided by L equals n. That's telling me that the number of volunteers equals 2 divided by L, or the length of the road each person's cleaning. When I go to do the calculations now, it makes me no longer have to solve this equation. Notice if I was using the second equation we just wrote for the first problem, it would say 2 divided by the length of the road, which is 0.4, equals the number of volunteers. Look at that math there. 2 divided by 0.4, that's exactly what we did here to get our answer earlier. So it would mean that if I gave you a bunch of different mile lengths and asked you to do this calculation, it would mean we wouldn't have to do all this solving each time. We could just substitute it in to find the answer. That's what we're going to be able to do for this last one here. So go ahead and try this one. If each person is cleaning 2/7 of a mile, how many volunteers were there? All right. Well, if each person is cleaning 2/7 of a mile, means 2/7 is our length of the road. So I'm going to take 2 and divide it by the length, which is that 2/7. Now, I could put a fraction and a fraction. Some people also find it helpful to instead change it to a decimal. It is up to you. If we're doing it as a decimal, I think that is 0.285. So we get that equals N, are our number of volunteers. When you go to divide that, 2 divided by 2/7, or that 0.285, is going to give you 7 equals N. In other words, there are 7 volunteers. And thinking about it with our first equation, we said if I gave you the number of volunteers, you're taking the 2 miles divided by the number of volunteers equals how many miles they're cleaning. Notice if we had 2 miles divided up by 7 volunteers, it's 2 divided by 7. Each person's cleaning 2/7 of a mile. This last part here is asking, write an equation that would make it easy to find the number of volunteers, N, if each volunteer cleans up a section that is L miles. So using these same variables as before, what would that equation be that would make it easy to find the number of volunteers? We've already written 2 equations at this point. Let me circle them for you in red. One of our equations, oh, look, one's already circled. One of our equations is right here. And then we wrote a second equation right here. Kind of like that warm-up question, right? There's 2 different equations here that represent the situation. Which equation would make it easy if you're trying to find the number of volunteers? Well, if you're trying to find the number of volunteers, if you're trying to solve for N, this equation here is going to make it easier because that equation has been rearranged to tell you this is what equals N. This is what equals the number of volunteers. So 2 different representations for this situation, but depending on the information given to you, one might be a little easier to use than the other. We're going to practice the same thing again down here with this new situation. Number 1, it tells us a tank A initially contained 124 liters of water. It is then filled with more water at a constant rate of 9 liters per minute. How many liters of water are in tank A after the following amounts of time have passed? Let's pause here. What's going on in this situation? Well, we've got a tank. And what do we know about the tank? It's starting off with 124 liters of water. So we've got a tank. There's some water in it. What's happening as time goes by? Well, we're filling the tank with more water. We're filling it with 9 liters of water per minute. So each minute that goes by, there's another 9 liters of water that have been added to that tank. So we've got the starting point, and then we're adding 9 liters every single minute. We've got the question, how many liters of water are in tank A after the following amounts of time have passed? I'm going to have you go ahead, pause the video, and try A and B for me. All right. Well, after 4 minutes, the first thing I would want to figure out is how much water has been added. We know 9 liters are being added each minute. So after 4 minutes, that would be 9 liters per minute times the 4 minutes, we've added in 36 liters of water. Liters. There we go. Now that's how much water has been added. How much total water is in the tank? Well, it started with 124 liters. And then we've added those 36 liters during those 4 minutes. So that ends up being a total of 160 liters. Now for the second one here, they tell us 80 seconds. It might be tempting to start off the same way and say, okay, well, that's 9 times 80. But that is not what we want to do here. Think about it. Why wouldn't I want to do 9 times 80? Well, we're given that it's increasing or being filled at a rate of 9 liters per minute. And I'm trying to emphasize that word minute here. If you do 9 times 80, you are calculating how much water has been added after 80 minutes, not 80 seconds. So we're given this rate here in liters per minute. In order to figure out what I need to multiply by, I need to figure out 80 seconds. How many minutes is that? Is it 1 minute, 4 minutes, 80 minutes? It's definitely not 80 minutes. Well, in order to figure that out, our goal, remember, is to figure out how many minutes is 80 seconds. Well, we know 80 seconds, well, it's got to be over a minute because 1 minute is 60 seconds. What we can do is take the 80 seconds and divide it by how many seconds are in a minute, which is 60 seconds. When you do that, that's going to give you 1 1/3. So 1 minute and then 1/3 of a minute, or 1 minute, like 20 seconds. If I want to write that as a decimal, that's 1.3 minutes. Basically, 1 minute and a little more. So when it comes to calculating how much total water is in that tank, I'm taking the 9 liters per minute, and I'm going to be multiplying it by 1.3 minutes. That's like a 1.33 repeating too. 9 times that 1.333 repeating is going to give us 12. And then don't forget, we still need to add in the original liters of water, which would end up giving us 136 liters. Now, this last part is minutes here. And this is similar to what we've done in some past lessons. Represent this situation here. If we don't know how many minutes have gone by, writing an equation that tells us how many liters of water in the tank. Well, you can use this pattern here of what we've been doing, or this trend here of what we've been doing, to help you write this last part. Each time we're taking 9 and multiplying that by how many minutes go by. So you can write that as 9m, or you can just write 9m. And then after we've done that, we add in that starting amount. So we could say 9m plus the 124. That expression right there represents how much water is in the tank. And if you wanted to, you could even say like equals W for total liters of water. But we get 9m plus 124 there. Now when we come down to the next part, it's going to be similar to what we've done, except I'm switching the information we're given. So now we've got how many minutes have passed m when tank A contains the following amounts of water. So we're trying to figure out now the time, the minutes, if I tell you how much water is in the tank. So the first 2 are for you to try. Go ahead, pause the video and try those 2 now. Well, for A, if there's a total of 151 liters after some time has passed, first thing we could do is take the 151 and subtract out that starting amount of water. When I do that, I'm left with 27 liters of water. If I'm taking out that starting amount, that's going to tell me how much water has been added over the time. If 27 liters of water have been added as time has gone by, remember there's 9 liters of water being added per minute, we could take those 27 liters and divide it by the 9 liters per minute, and that tells us, well, 3 minutes must have gone by. You could always double check by doing the same math you did up here. If 3 minutes have gone by, 3 times 9 gives us the 27. And then when we add in that starting amount of water, it takes you back to the 151 liters. This next one here would have been a similar process, just with even more fun math. We're going to take that 270.25 and subtract out that starting amount of water. That leaves us with 119.25 liters of water. When you divide that by that rate, it leaves you with 16.25 minutes. So 16 minutes and then some seconds. For this last part here, we want to write an expression similar to what we did up here for C for P liters. So if we don't know how many liters, can you write an expression like you did up here? Well, just like before, you can use this pattern here to help you represent it. So we could say, well, each time I'm starting with the liters of water. So I'm starting with P. That's not the letter P. I'm starting with P. And then each time I'm subtracting out that starting amount. I'm starting with P and I'm subtracting out the 124 liters. Once we get that answer, I divide it by 9. So once I figured out what this equals, whatever that value is, I am dividing it by 9. You could write it like that, or you could write it as I first need to do this. And I'm using that word first there because I'm going to put parentheses around it to show that I need to do that first. And then after I've done that, I'm dividing it by 9. Both of these here say the same thing. That is one way you could take this information and represent it with an expression for P liters. The other way we could have done it is, remember before we had already written this out. And I said, if you wanted, you could even say 9m plus 124 equals, I believe I used W in that initial example for waters, but notice down here they're using P for liters. So let me switch that to a P. What they're asking us to do here is, can you write an expression for how many minutes have passed if there's P liters? If I don't know P, could I rewrite this equation here to tell me what M is, or to tell me how many minutes? So the other way you could approach this is, we've got this equation here from earlier. Let's solve this equation. Instead of for P, let's solve it for M, because the second part here is finding how many minutes. So let me do that. Let me locate some space on my paper. I'm going to take this. There we go. Let me take this equation here and solve it for M. Well, if I had this equation, the first thing I would want to do to solve for M would be get rid of that constant, get rid of that 124. So I'm going to come in and I'm going to subtract 124 on both sides. When I do that, what am I left with? Well, 124 minus 124, that's 0. That's nothing. Those cancel out. And so I'm left with, on that left side, 9m, and then equals, on that right side, it says P minus 124. I'm just going to write P minus 124. Notice that's the first part we have here. We've got, each time I was taking whatever that amount of liters was and subtracting 124. Now the second part to solving this equation here, if I want to solve for minutes, means I want to get m all by itself. I want to get rid of the 9. Right now this says 9 times m. When you're solving things, you're always doing the opposite operation. So instead of multiplying by 9, I could divide by 9. And we saw in an earlier lesson and equivalent equations, when you're talking about dividing on both sides, you want to make sure you divide the entire side. So that I'm going to draw that division line going all the way across. When I do that, those 9s cancel out. So we're left with m all by itself. We get m equals, look at this weird looking, fun looking fraction right here. I can't do any of that math since I don't know p. So it's just going to equal exactly that. And to save you the time of watching me try to write all that down, I'm just putting an arrow there. So we get m, or the number of minutes, equals p liters minus 124, all divided by 9. Look, that's what we had earlier. We had p liters, so take the liters, subtract 124, and then divide by 9. So this right here is the other way you could find this last one here, is rearranging the equation for that other variable. And come down, look, there's another tank here. We've got tank B, which initially contained 80 liters of water, is being drained at a rate of 2.5 liters per minute. How many liters of water remain in the tank after the following amounts of time? One of the times given is an actual number that we can calculate. The other one is a variable. So similar to before, if it's a variable, I'm not going to be able to do any calculating. It's just writing that expression to represent it. Go ahead, pause the video now, get some practice in for yourself, and try number 3, parts A and B. All right, so for this first one here, there are 7 minutes have gone by. Well, what's happened? We've started with 80 liters of water, and it's draining. It's losing water this time, 2.5 liters per minute. So after 7 minutes, how much water has been drained? Well, 2.5 liters per minute times the 7 minutes, that ends up giving us 2.5 times 7, 2.5 times 7, which is 17.5 liters of water have been drained. We were starting with 80 liters of water. So if 17.5 liters have drained out, how much water would that be left over in the tank? Well, 80 liters is our starting point, and it's drained 17.5 liters of water. So if I take 80 and subtract 17.5, that leaves me with 62.5 liters of water. Question is, how many liters of water remain in the tank? That's how much water is remaining. What about T minutes? What if I didn't tell you how much time would go by? Can you write this expression that represents how much water is in the tank? Well, what did we do? We're starting with 80 liters of water. It's being drained, so I'm taking out some water. And I'm taking out 2.5 liters of water per minute. Well, it would be 2.5 times the number of minutes, just like we did up here, except now the minutes is just T. So it says 80 minus 2.5 T. That would be the expression that represents how much water is in the tank after T minutes. Now let's flip it around again. So for how many minutes T has the water been draining when tank B contains the following amounts of water? So flipping it around, if I tell you some time has gone by, there's 75 liters in the water, 75 liters in the tank, how many minutes must have gone by for that to be true? I'm looking up here, I see after 7 minutes, there is this much water left. So it means less time has gone by, but how much time? Again, make sure you're getting the practice in. Pause this video now, try parts A and B, and then come back when you're ready. Let's see. If there is 75 liters of water in the tank, and it started off with 80 liters, how much water has been drained? You might be able to do that math in your head, but what we're going to do is that 80 minus 75, that means 5 liters of water have been drained. Okay, so there's a total of 5 liters of water that have been drained. If 2.5 liters are being drained per minute, how much time has gone by then? Well, we got to take the 5 liters that have been drained and divide it by the 2.5 liters per minute, and that leaves us with 2. 2 minutes must have gone by. Looking at 5 liters being drained, that makes sense. 1 minute is 2.5 liters, so double that, 2 minutes would be 5 liters. And if 5 liters have drained, 75 liters are left. So now I like to use the word abstract. Let's abstract this and write it an expression down for any amount of water, any amount of liters. So if I'm doing that, remember there was 2 ways we could do it before. We could take that first expression we wrote and solve it for the other variable, or based on this math you've been doing, we can come up with an expression there. I want to try doing this solving method since that's really our focus for this lesson. Remember, it's called which variable to solve for. So I'm going to approach this with solving that first expression. We had this first expression, which I will put down here in red. We had 80 minus 2.5t. that expression there was telling us how many liters of water were in the tank. So I'll say that equals V liters. If I want to write an equation instead for how many minutes have gone by, means I want to rearrange this equation for t, for time, or our minutes. In order to do that, let's start by getting rid of the constant. Just like if I had given you this equation, but it says instead equals like 100 instead of V, you would always start by getting rid of that constant, that 80. And we get rid of the 80. How would you make 80 0? Well, you would subtract 80. So I'm going to come in and I want to subtract 80 on both sides. Now, when I do that, what does that leave us? Well, 80 minus 80 is 0. It cancels out. That was the whole point of this, right? We wanted that to cancel out. So all that's left over there on that left side is that negative 2.5t. On my other side, I've got V minus 80. I can't actually subtract that. We don't know what V is, so I can't subtract. Instead, all I can do is just write V minus 80. Our last part, I'm trying to get that time all by itself, or t. So I want to come in here and divide both sides by negative 2.5. If I get rid of that negative 2.5, it gives me t all by itself. I need to divide both sides by negative 2.5. So I'm going to flip over to my little pen here to say those 2.5s are canceling out, so we're just left with t all by itself. And on our other side, we've got the V minus 80. And all of that there is divided by that negative 2.5 there. So that could be our expression for how much water is in the tank after, how many minutes have gone by if there are V liters in the tank. I've been so tongue-tied this week. I'm sorry. So we get that right there would be our expression. So to kind of help us summarize here what's going on in this lesson, I've got a few questions for you. The first is, what does it mean to solve for a variable? In these problems, I've been talking about, we're going to solve for V, we're going to solve for T. Ultimately, what does that mean? Well, solving for a variable means getting that variable by itself, or you might hear isolating the variable, which just means get it by itself. If I wanted to solve this equation here for T, I'm trying to get T all by itself to come up with an expression using V, or V liters. Now, why should we solve for a variable? Why would we want to do that? Well, you'd want to do that because depending on what the question is asking you to find, and with that, what information you're being given, some of these equations make the calculations a lot more easier to do than others. If I'm looking, for example, at this equation here, and where did it go? This first equation here. If I were to ask you if I don't know, 10 minutes have gone by, how much water is in the tank? If I give you the time and I'm asking you for the water, which one of these would be more helpful? Well, if I'm giving you the time and asking you for the water, the equation that's set up to equal the liters of water would be more helpful. If the opposite of that would be, if I were to tell you there's 10 liters of water left in the tank, how much time has gone by? I'm asking you for the time. The second equation here would be more helpful because it's already set up with T equals. So by rearranging these equations and solving for a variable, it helps make your calculations more simpler when you go to actually use the equation. So that brings us to the last part. How do we actually solve for a variable? How do we do this process here? Well, it's pretty similar to what you already know with solving equations. Notice up here, I was starting with the constant. That's the same as equations that only have one variable in them. The part that becomes different is just your answer isn't going to be a number. It's got a variable in it. But we solve for variables the same way we solve equations just with one variable. Our goal is to get that variable by itself by doing the opposite operation each time. That is the end of this lesson. Remember, this is a 2-part lesson here. So this was the first part. We are going to continue with this topic on Monday in part 2. Until then, have a wonderful rest of your day, and I will see y'all later. Bye.